Okay, so good morning everyone. So for today's lesson, means today's seminar, okay. So I'll be teaching Form 4 Chapter 6, especially for salt, okay. For essay never for fun, I think I don't have time to teach, okay. So that's why I focus on more on the 6.8 onwards, 6.8, 6.9, all the salt, solubility of salt, heating of salt, and also ion and ion test. Okay, so let's straight away go to it. Okay, so by the way, this is the answer, okay, and answer and the additional material uh for you. So you can scan your QR code, okay, to get the extra answer. Because I'm sure we couldn't finish everything. We couldn't finish everything um in a day. Okay. I mean in these 2 hours. Okay. So let's look at how do we know which one is soluble, which one insoluble. Okay, this is the solubility of salt. Okay, so now first of all, which salt you need to determine that it can dissolve in water. Okay, so first of all, because this is a basic, okay, basic because later on we need to apply this solubility of salt to other parts of the question, parts of the lesson. Okay, so if you look at it, okay, so which salt are soluble? First of all, the number one prioritize is SPAN, okay, SPAN, spun salt, okay, spun salt all are soluble, okay. Spun stand for what? Stand for sodium, okay? Na plus, sodium ion, potassium, ammonium nitrate salt, okay. These four, okay, these four actually are all soluble, okay, soluble. Now, this is the number one prioritize. Later I explain what it means when I prioritize this. Okay, so all these are soluble. First of all, we got spun. Okay, spun salt soluble. Okay, then second we got carbonate. Okay, carbonate salt, metal oxide, and metal hydroxide. Okay, means you got either the carbonate, oxide, and hydroxide. All these three. Okay, we call it like COH. Okay, COH. All are insoluble. Okay, all are insoluble. Okay, CO means stand for carbonate. O stand for oxide. OH stand for OH minus, which is hydroxide ion. Okay. Then wait, so span you can stand for Na plus, K plus, NH4 plus, and also NO3 negative. Okay. Final one. Okay. So now I ask you one question. Okay. So let's say NaCl is soluble. Yes, because we got Na. Okay. Or like KCl, is it soluble? Yes. Okay. Or like for example, K2CO, K2CO3. Now, what if I got K, I also got CO3? Okay, do you think it's soluble? Now, when these two meet, soluble and insoluble meet, now this will come first, spun will come first. Okay, meaning it is soluble. Okay, because got K. Now, number one, all the spun doesn't matter. Meet with who, it is soluble. Okay, doesn't meet with soluble or insoluble, it's still soluble. Okay, but carbonate or COH all are soluble, all are insoluble, sorry. Okay, except when you meet spun. Okay, except when you meet spun. Okay, then it is soluble. Okay, for meeting spun, it is soluble. Okay, now the third one. Okay, third one you got chloride and sulfate. Okay, chloride and sulfate. Okay, all these are also soluble. Okay, except you got few, like for example, PAH. Okay, PAH, which is insoluble. Okay, insoluble. So you got PB, okay, PB, VA, VA plus, AG plus, and HG plus. Okay, so they're all insoluble. Okay, except three insoluble, PB, AG, HG. Okay, so you can half like this, okay, half like this. Okay, so you got pH. Okay, the CM minus you assume as curry. Okay, assume as curry. So means you can memorize not to say anything particular, okay? Just the way to memorize. Like in school, I'm sure you have certain card with okay? Certain card, certain satuan this, okay? Can memorize it? Remember kali is persatuan harmonic into, okay? Or the other one is suffix ion, okay? Suffix ion, you got soap, okay? Soap, okay? Soap which is all soluble also, SO4 2 negative, okay? Except this PbVaCa, okay? PbVaCa. Now, all these are insoluble when you meet it SO4 2 negative. Okay. So the way you memorize is you remember the soap, okay? Soap drinking soap, okay? You remember this one? So okay. So there you go, you can memorize PaH. When you meet Cl minus, it's insoluble. PbC, okay? When you meet SO4 2 negative, it's also insoluble. Okay. So okay. Okay. Move on. Okay. So we look one by one. Okay. We tick or cross which one is soluble, which one insoluble. Okay. First of all, okay. So you got NO3 negative, K plus, Na plus, NH4 plus. Okay. Now all these are you have to tick first. Okay. Because all of them are soluble. Doesn't matter what. Okay. This is the first thing that we prioritize for span sort. Okay. All are soluble. Okay. Span salt. For sodium salt, potassium salt, ammonium salt, and also nitrate salt. Okay. So move on to the other one is the second rule is COH. Okay, COH. So COH look at CO2 negative, O2 negative, and OH minus. Okay, all these are insoluble. Okay, you have me to tick, you have me to cross. Okay, but of course when they meet spa, then is where is soluble. Okay, all these are for insoluble except when they meet spa. Okay. Okay, so after that, okay, the last rule is the Cl negative. Okay, Cl negative uh is also all soluble. Okay, except three lah, except three, except Pb2 plus when they make Ag plus, Hg plus. Okay, then it's all insoluble. Okay, so you take this, yes, insoluble. Pb plus insoluble. Wait, I highlight the other color. Okay. Okay, so choose the other color. Okay, so tick, tick, cross, tick, 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 all soluble. Okay, except three lah. Okay, so 1, 2, 3 are insoluble. Okay. Okay. Now Cm minus is also same thing as Br minus and I minus. Okay. So Br minus and I minus. Okay. So all these are because all these are group 17 halogen. Okay. So we also have the same characteristic. Okay. So you have to take also except for Pb, Ag, Hg. Okay. Okay. So move on to the last one is SO2 negative. Okay. Okay. After that, okay, you got the last one is SO2 negative. SO2 negative all are soluble except Pb, Ba, Ca. Okay. So you have me to take also except Pb, Ca, and Ba lah. Okay. All are the other one is soluble. Okay. One, two, three are insoluble. Okay. So this is a solubility of salt. Okay. This is level one. Okay. The bottom one is level two. Okay. So you got the thing and cross. Okay. First of all, you find out all the spun salt first because spun salt all soluble. Okay. Spun salt all soluble. Okay. Spun salt stand for Na plus, K plus, NH4 plus, NO3 negative. Okay. So I need to highlight first. First of all, Na plus, okay, NO3, K, Na, NH4, NO3, nitrate, okay, Na, nitrate, NH4 plus, Na, NO3, K, NH4, NO3. Okay. Time to find out all the spans of first. Nitrate, NH4, NO3, NO3. Okay. I think I didn't miss anything. Okay. So okay. So have to take everything for this. Okay. So after that, okay, you also move on the next one, which is COOH. Okay. COOH, okay, insoluble. Okay. COOH stand for CO stand for carbonate salt. Okay. Oxide stand for side. Okay. O2 minus. Okay. The other one is OH minus, which is also insoluble. Okay. So except when you mix span, okay, except when you span, all are insoluble. Okay. So you have to find out for the CO3. Okay. Now, by the way, why I don't include O2 minus and OH minus? Because they are base. They are not actually salt. Okay. They are base. Base is not salt. Okay. So let me highlight for the carbonate, all the carbonate first. Okay. But except when you take already, okay, take no need, okay, because already considered insoluble, insoluble. Okay. So you got carbonate here. We should have a highlight. 1, 2, 3, 4, 5, 6, okay, 7. Now all this you have to put cross. Okay. Move on. The other one is Cl minus. Okay. Cl minus all are soluble except three. What? Okay, so you got Pb, Ag, Hg. Okay. All these are insoluble when the meat is Cl minus. Okay. So I'm going to find out the Cl first. Okay. Which one got Cl? Wait a minute. Okay. So this one is Cl, 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 Cl. Okay. So I'm going to put tick except Pp, Ag, Hg. Okay. So you can tick. Yeah, you can tick here. No, check cannot tick. Okay. Sorry, wrong. Cannot insoluble, insoluble, insoluble for 3. FeCl3 is soluble. Okay. Wait a minute. Okay. So after that, you have to tick except Pb, Ag, Hg. Okay. So tick, tick, tick. Okay. So these 3 insoluble. Okay. 1, 2, 3. Okay. For PbCl2, AgCl, HgCl2. Okay. Sorry, repeat one time. Which is first of all spun salt. Okay. Can't hear you. Can't hear you. Eh? Why me can't hear you? Wait Oh, can. Oh, I thought you cannot can hear anything. Okay. Okay, wait. Okay. So, you just join or wait Wait a minute. Oh, yeah. Okay. Okay, don't worry. Oh, okay, wait so you understand solubility of salt? Okay. So, okay, wait. First of all, the QR code you save for answer. Okay. After that, for the sodium, potassium, ammonium nitrate. Okay. So I just repeat every one time. Okay. So if you miss the fun part, don't worry. Okay. You can actually watch back the YouTube. Okay. I post very soon. Okay. So you can review back. Okay. So basically, I sum up. Basically, is first of all, spun salt. Okay. Spun salt is actually soluble. Okay. Spun salt stands for sodium ion, potassium ion. Okay. Sodium ion, potassium ion, NH4 plus, NO3 negative. Okay. Ammonium salt and nitrate salt. Okay. After that you got okay. That's why I take everything up. First of all, I take everything for nitrate. Okay. And also for NH4 plus, K plus, okay, Na plus. This okay. I take everything because they are all soluble. Spun salt. Okay. I'm not sure if you still remember. Okay. Okay. So second. Okay. Second is carbonate salt. Okay. Carbonate salt is COH. Okay. COH stands for carbonate oxide hydroxide. All these are insoluble. Okay. They are not soluble in water. Okay. So I put cross up, except when it is spa. Except when it is spa, because spa is the first to be prioritized. Okay. So that's why for this, okay, carbonate all are insoluble except when it is spa. Okay. When it is spa, then spa is everything. Okay. Spa is soluble. Okay. So you got O2 minus, same thing. O2 minus insoluble. You got OH minus insoluble. This is the first part. Okay. And repeat one more time. Okay. So the those who maybe like later on, if you watch YouTube, then I repeat one time. Then if you don't watch, then you can skip. Okay. After that you got Cl minus. Okay. Cl minus means what? Cl minus all are soluble. Okay. All soluble except when you can remember as Kali Cl minus. Okay. Kali means like there's 3 lah. Pb 2 plus, Ag plus, Ag plus, Hg plus. Okay. Okay. Say for PaH lah. Okay. This one. Okay. All are insoluble. Insoluble for this. Okay. Insoluble for this. Okay. I mean for Cl minus, Pb2 plus, Ag plus, Hg plus, all are soluble. Okay. Except when you make Pb, Ag, Hg insoluble, SO2 negative, SO2 negative, All are soluble, same thing, except we admit PB, BA, CA. Okay. Then insoluble. So that's why Cl minus, everything I put tick, okay, except PB, AG, HG. Okay. Or Br minus, Cl minus, Br minus, I minus, all are, you learn in formal chapter 4 that they are all halogens, group 17 halogens. Okay. So that's why they are all soluble. Except three things, which is PB, AG, HG. Okay. So I highlighted it up. Okay. So after that, the last one is sulfate. Okay. Sulfate is PbBaCa insoluble. PbBaCa insoluble. Okay. All the other one soluble. Okay. So okay, this table, sorry. Okay. Okay. Then also here also repeat one time. Okay. This is level 1, this is level 2. Okay. So that's why the span law again, I find out everything the span. Okay. For example, I highlighted all the brown color one. Okay. Na, NO3, all these are I highlighted brown color. All are soluble. You have to tick. Okay. Have to tick everything. Then carbonate insoluble, green color. Okay. Insoluble. Except when I highlighted the first one, I'm going to K. Okay. Because already this one is being prioritized. Okay. K is being prioritized. So it's all the soluble salt. Okay. Okay. Wait a minute. Okay. Then after that you got Cl. Okay. Cl. Now why the reason why I put O and OH minus, because O and OH minus are not salt. You learn in formal chapter 6 that they are base. Okay. Based on all the acid. Okay. So base. Yeah. So we don't include as salt. Okay. Okay. The last one is Cl minus. No? Cl minus all are soluble. Okay. You have to find out all the Cl minus except when you take a little. Okay. Cl. Okay. All are soluble except three. BCl, AgCl, HgCl. Okay. So Cl all soluble except PbAgHg. Okay. Because we learn this solubility first because later on we apply a lot of things. Okay. Last one. Okay. SO4 2 negative. SO4 2 negative. All are soluble. Okay. Except when you got Pb2 plus, Ba2 plus, and Ca2 plus. Okay. You have to find everything that wait a minute. Okay. Which can highlight blue color. Okay. Wait. Blue color. Okay. So having to find out SO4, 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 okay, SO4, SO4, and SO4. Okay. All the SO4. Okay. After that, you have to tick and cross. Okay. Except three. PbVSA. Okay. So this one insoluble. Okay. The other one CSO4, yes. Okay. PbSO4 cannot. No, cannot. Okay. BSO4 also cannot. So the other one, take lah. Okay. So you got three that are insoluble. Okay. For SO4, you got CaSO4, you got PbSO4, you also got BaSO4. Okay. I'm not sure you have so many colors or not. Okay. But this is the idea. Okay. I'm not sure you have many different pen color or highlighter. Okay. So if it's the case, then it's better for you. Okay. Got. Okay. You need to copy it. Tell me. Okay. You take your time there. Okay. Then you finish, you tell me. Okay. Or you want the top one also can. I can just screenshot. Okay, screenshot. This one screenshot already. Everything screenshot already. Okay, move on. Okay, so this is a solubility of salt. Okay, after that you also will learn how. Okay, so you learn how to prepare salt. Next part. Okay, next part how to prepare salt. Okay, so move on. Okay, so this one is the before that, which branch you come from? I think I never see your name. Is it your Gasing? Okay. Okay. Move on next. Okay. So look at page 3. Okay. Okay. So after that, you got this one, learn for spun salt, COH, and all the sulfate chloride salt. Okay. So the reason you need to memorize this also because you need to learn how to prepare salt. Okay. So we prepare 3 salt. Okay. First of all, soluble salt, you got 2 types. Okay. First, soluble, you got soluble spa salt. Okay. Soluble spa salt. Spa stand for what? Spa stand for Na plus, A plus, and NO3 negative. Okay. And not NO3 negative plus. NH4 plus. Okay. Okay. After that, now this soluble salt how to prepare. Now we look at more detail. Okay. Look at the first one. Okay. Look at page 4. Now, this is a shortcut by the way. Okay. Now I teach you how to see the shortcut. Okay. So first of all, let's say you want to prepare NaCl. Okay. NaCl because Na is a spa salt. Okay. But they are also soluble. Okay. So if you want to prepare, very simple. Okay. You using neutralization reaction. Okay. Neutralization reaction. Neutralization reaction is between acid and alkali. Okay. It's between an acid and an alkali. So how? Acid and alkali, that's when you remember that you need to have 2 ion for each for each. Okay. So for acid you need to have this ion. Okay. Acid you need to have H plus. Okay. So you got H. You put at top. Okay. And also you got OH minus for alkali. You still remember in form 1 chapter 6 lesson. Okay. So this one is for OH. Okay. OH minus. H plus, OH minus. Okay. So that's why how to prepare NaCl? First chemical is you use HCl. Okay, you cross HCl. Second, okay, you got NaOH. HCl, NaOH. Okay, so that's what you get NaCl and H2O. H and OH you get H2O. Okay, so I need to use these 2 chemical to prepare. Okay, this neutralization reaction. Okay, so still remember to do the steps. Okay, the steps. I see some of the even the school or some sort of school trial. Okay, so they ask for this some of the precaution step, not precaution, experimental steps. Okay, how to prepare salt, how to prepare NaCl, how to prepare the other salt. Okay, so I agree. I explain. Okay, so I'm sure you have done this titration. Okay, in last year. Yeah, so I think you still have a bit of memories. Okay, so first of all, okay, you pipette. Okay, your alkali need to be pipetted. Okay, pipette is like this. Just in case you never see the shape. Okay, look something like this one. Okay, so this one you put around 25 cm cube. Okay, now in exam you have to mention pipette what? Pipette 25 cm cube, 2.0 mole per dm cube. Okay, now you have to mention the concentration. You also have to mention the volume. Okay, don't forget. Later if no other they share. Oh, this one no concentration, no volume, they're wrong. Okay, so you put inside potassium hydroxide solution, you pipette, then you transfer into conical flask. Okay, conical plus this one. Okay. So you put inside. Okay, this is the first step. Okay. Second, you add a few drops of phenolphthalein indicator. Okay. Now you also learn some of the indicator like phenolphthalein, methyl orange, and also your universal indicator. Okay. But normally you put phenolphthalein. Okay. So phenolphthalein, you put a few drops using your dropper. Okay. Drop 1, drop 2, drop, or 3 drop. Okay. Then you swirl the flask. Swirl means not shake. Swirl means you try to just within a circle. Okay. What's the color of universal indicator? Okay. For acid it's red color. Okay. For for neutral is yellow color. Okay. I think you can check it. For alkali is green color. Okay. But normally we don't use universal indicator much. Okay. Normally okay. We put phenolphthalein or methyl orange. Okay. Also can one of the indicator is also can use universal. Okay. So phenolphthalein colors colors for most of the part. For acid and neutral is colorless. But when you put inside alkali, there's one color form. There's pink color. As you can see, pink color form. Okay. So then after you try to swirl, okay. Swirl not swirl is not shake. Not shake. This shake swirl is just like a circle. Okay. You just draw a circle like this. So you know, okay. Because cannot shake if you shake everything come out, okay, pour out, okay. So after that the third one you got yeah, that's why. Okay, so third one you got fill the burette with 2.0 mole to cube. Okay, hydrochloric acid, of course they put acid because this is between acid and alkali. Okay, so you put inside acid, you put inside what? Put inside the burette. Okay, burette. Okay, so then you clamp with the retort. Okay, after that, of course acid also you have to say what is the concentration. Okay, but of course you know it to say volume. Volume you get to know after the experiment. Okay, after you finish experiment, then you get to know. Okay, then you calculate, then you record how much volume needed. Okay, so the fourth one is you add acid into conical flask. Okay, slowly. So here got one pipe one. Notice here one pipe. Okay, one small pipe. Then you try to turn the pipe on. Okay, but of course slowly. Slowly doesn't mean like you open the pipe big, then you let the everything acid just flow very fast. No lah. Okay. Then that one I'm sure you cannot get the result. Okay, so you need to get slowly one by one drop. Okay, need to be patient. Okay, patient. Okay, then that's why they say roll slowly. But also when one by one dropping down the alkali, you also trying to swirl. Okay, until what? When you stop, until all the pink color become colorless. Okay, become colorless. That's when you become neutral. Okay, that's when alkali totally become neutral. Okay, then you can stop the experiment. Okay. Okay. After that, then you repeat the experiment without phenolphthalein. For normal titration, 1 to 4 is enough. Okay. After you just repeat the experiment. Okay. For second time, third time to confirm the average. Okay. But for this one, since you want to, the main reason you do this is not to see the reaction between them, not to see how much volume of acid needed. You want to see that. Okay. You want to see wait, somebody want to join with us. Okay, so so you repeat the experiment without phenolphthalein. Okay, why you cannot do without? Why you cannot do with phenolphthalein? Okay, simple reason. Okay, because okay, I want to prepare a pure salt. Now I want to prepare pure NaCl. Okay, the NaCl inside I cannot contain any water, anything. I don't want. Okay, I only want to get the pure NaCl. So I cannot have phenolphthalein inside also. Okay, so the first experiment, I add KOH with phenolphthalein. Okay, so second time I don't repeat phenolphthalein. Okay, but how do I do if I without phenolphthalein? Okay, But how do I know the color change from pink to color salt? Okay, so very simple. Because you already did the first one. The first one, let's say you already record. Okay, this one is I need 20 cm cube of acid. Okay, so now I already know. Now I do a second time with the same amount of this. I already know. Oh, this one also I need 20 cm cube. That's all. Okay. No need to see the color changes anymore. I know 20 acrylic. Okay, 20. That is okay. So that's why I say same volume of acid. Okay. Then after that, finally you get a pure salt. Okay, you get NaCl. Let's say you get NaCl. But the problem is NaCl is insoluble. Okay. NaCl is not insoluble plug. NaCl is soluble. Okay. Na, sure lah, sponge salt soluble. Okay. My mistake. Okay. So Na soluble. Soluble means what? Soluble means you cannot see the salt. Soluble meaning you cannot see the salt. Nah, so you cannot see the white powder, white precipitate, nothing. Just a solution, just a water solution. Okay. So how will you force the salt up, the crystal salt up? Okay. So that's when you need to do these few steps. Okay. Now you need to heat and cool to force the crystal salt up. Okay. Now you use evaporating dish. Okay. So you heat. Okay. You heat until 1/3 of its original volume. Okay. Now you use evaporating dish because the surface area is bigger. Okay. So that it can easily evaporate. Okay. Then after that you left 1/3. What you do is you allow to cool. Okay. After cool, crystallization you occur means you get the blue like or blue purple some of the salt coming out. Okay. Then you take out the salt. Okay. How? By using filter. Okay. Filter. Okay. You filter it, then you rinse it. Okay. You filter all the water out. Let's say all the solution out. I only want the pure NaCl, which is in solid form. Okay. So I filter, I rinse. Okay. Rinse with a little bit of distilled water. Rinse meaning I'm trying to wash. Let's say I want to get pure NaCl. Okay. I don't want anything around my NaCl. So I want to wash cleanly. You call it rinse. Okay. Rinse a bit. Okay. Just like your vegetable. When you buy a vegetable, you try to rinse a bit. Try to rinse so that it get cleaner. Okay. So now finally you dry it. Okay. We dry between sheets of filter paper. Okay. There's the 5 steps. Okay. These 5 steps you got heat, cool. Okay. Got heat, cool, filter, rinse, dry. Okay. The rinse dry. Okay. So I heard about the method you can remember. Okay. So you can remember this way. Okay. And next time I think the other way, the other method or the other method. Okay. So people can try it dangerous. Okay. Heat, cold, filter, rinse, dry. Okay. So is that okay? Any problem? So this is how to get a pure soluble spark salt. Okay. These are the 5 steps. So this is a discussion as well. Okay. Discussion. So why you need to use phenolphthalein indicator? What's the reason? Okay. So the reason very simple. So that you get the endpoint. You can know when you need to stop titrating. Okay. Second, why should not phenolphthalein indicator be added to VCM cure? Why the 5th step happen? Why don't use phenolphthalein? Okay. So reason I want to get pure salt solution. Okay. Third one, like we have to rinse. Why to rinse? Rinse with a little bit of distilled water. Okay. So only a little bit amount. I cannot wash too much. If you wash too much, then the salt, some of the salt will gone. Okay, you'll be gone. So you only wash a little bit of water. Okay. 4th one is the equation. Okay. 5th one is the other type can do spark salt. You can also prepare KCl, NaCl, and H4Cl. Okay, or nitrate okay. Okay, as long inside contains spark salt. Okay, sodium, potassium, ion, ammonium. Okay. Okay. This is the step. Okay. So you can, in essence, you can, before exam, let's say you come out, okay, you can try to read through it, okay, try to read through it, okay. So you can have a little bit of idea to blow some answer out, okay. I know it's a bit heavy for this because it's not easy to memorize everything, okay. But if you understand the step, okay, it's so much easier for you to write out all the answers, okay. So you add acid, add alkali, okay. How many amount you tell out, okay. Add to your training as well, okay. Then after that, you just stop it, okay. You continue to titrate again until the color change to pink from colors. Then you repeat one more time, okay. Then you heat, cool, filter, rinse, dry. Okay. There's one student want to join, but I don't know what happened. Wait a minute. Uh, Wait a second. So sorry. Okay. Meanwhile, I ask for, I talk about second part. Okay. Second part is soluble non-spar salt. Okay. Soluble non-spar salt. Why is he keep asking me? Wait a moment. I send the link. Okay. Some answer. Okay. So soluble non-spar salt. Okay. So okay. After that, non-spar salt meaning not sodium, not ammonium, not potassium. Okay. So this one how to remember now. Meaning like other soluble sulfate other than spar. For example, magnesium nitrate, or the nitrate, or like um MgSO4, okay, MgCl2, okay. How? First of all, then after that you got what? What else can I do? CaCl2 or Cu nitrate. How do I prepare? Okay, first of all, okay. Now, before that, you need to know the reaction of acid. Okay, that's what acid. Okay, acid can react with four things. Okay, number one, acid can react with metal. Okay. Number two, acid can react with metal, carbonate. Okay. Third and fourth, acid also can react with metal oxide and metal hydroxide. Okay. This four one. Where this oxide and hydroxide is base, acid really base, stable. Okay. So in simple way is N, okay, MCO3, MO, and MOH. Okay. Now, the reason you remember this because you need to learn how to prepare soluble non-spar salt. Okay. So the second step, you can look at page 6. Okay. Page 6. Okay, so page 6 uh method 2. Okay. So example, if I want to prepare copper 2 nitrate, first of all, some of the thing ask yourself, okay, is this soluble or insoluble salt? Soluble or insoluble salt? Okay. Other than the first one, first one is spar. If you see spar, soluble, okay, soluble. Okay. So normally you ask yourself question like this, okay? Soluble, okay. After that, what you do is you using insoluble salt prepare, okay? Now, terbalik logik, okay? Soluble salt, you use insoluble salt to prepare, okay? Now, there are two things you know, okay? Soluble salt, what's the insoluble now? The insoluble salt, I talk about this size, COOH, okay? What I talk about is COOH, okay? Okay, after that, then we got H plus, okay? And H plus, because I told you, COOH, you react with acid, okay? You put acid also, then only got action, okay? So the first chemical is HNO3, which is nitric acid. Okay. Second, you got copper 2. Now, H is for acid. Okay. I told you about this now. Okay. Now, actually this one, other than the insoluble one, you also need to add acid. Okay. COH also stands for all the carbonate, oxide, hydroxide, and metal itself. Okay. So then yes, then you need to heat up the acid, then you put inside, they only reaction. Okay, they only can become copper nitrate. So okay. In this case, now simple reason, okay. Let's say all the COH, okay, COOH. Let's say, for example, I put metal, any metal like copper or copper oxide. Okay, copper oxide is black color salt, black color solid, black color solid. Okay, so this black color solid, imagine if I put inside the water, simply normal water, okay, do you think it will dissolve? Simply I just put normal water. Okay, cannot, okay, cannot dissolve. No. So what you do is you put acids. Okay. Let's say very simple reason. Okay. I put I put the I put the chicken. I put the human inside the water. Normal water lah. Okay. Do you think anything will happen? Do you think it will dissolve? Okay. Nothing will happen. Okay. So that's why you put what? Acid. Okay. Acid very powerful now. Acid. Okay. Imagine if you immerse yourself into acid, what happen? Okay. Okay. Of course, obviously no lah. Okay. If you put chicken inside also, of course, we put many chicken inside, then we slowly also dissolve. Okay, powerful man. So if you put normal inside, cannot have reaction. You cannot get soluble. This one, if you don't soluble, you forever your CuO is here. Okay, you won't get a Cu nitrate. Now, if you put HNO3, what happen? Okay, HNO3, you react with copper 2 oxide, you become copper 2 nitrate. Okay, the Cu you go and find, you go and find another partner. You go and find the NO3. Okay. So what happens in this case, also you have to heat up the acid. Okay, you have to heat up the acid. Okay. So what happens? Then acid, this is the first chemical. Okay, first chemical with acid. Okay. Second, copper is the first choice. Okay, you got 4 choices. You got copper metal, you got copper 2 carbonate, or copper 2 oxide, or copper 2 hydroxide. Okay, you got 4 choices. Okay, they are available to react with acid so that all of them can get your copper 2 nitrate. Okay, you understand? Okay, the problem is, okay, the problem is, if you only normally I will not recommend for copper. Okay, why not copper? Okay, so reason very simple. Okay, because you still remember the reactivity of metal? I think most of you also learn in Form 1 Chapter 1. Okay, I mean in science you learn. Okay, so in this case, okay, H plus is on top of Cu. Okay, what happens is this H plus, okay, this H plus H plus is more reactive than Cu. Okay, Cu is less reactive than hydrogen. Okay, so what's happening is that's why this copper is less reactive. Less reactive meaning is weaker person, weaker chemical, or weaker in this case. Okay, H plus stronger, so that Cu cannot run past the NO3, cannot take away the NO3. Okay, so that's why it's insoluble. If you cannot take away, then no reaction. Okay, no reaction. So any problem? So what I recommend in exam is you take carbonate or oxide. Okay, normally these two recommended. Okay, so any problem? This is how to prepare soluble non-spark salt. Okay. Okay. Also, how to prepare. Okay, but what is the experimental steps? Okay, first of all, you put this amount of acid, volume, or the concentrated state out. Okay, then you put inside the beaker. Okay, then what happens is you heat the acid first. Okay, heat the acid using medium heat. After that, you add copper 2 oxide powder. Okay, you use a spatula. Okay, spatula is a spoon. Okay, so you slowly add a copper 2 oxide powder and into the beaker. Okay, then meanwhile you're trying to stir. Okay, you're trying to stir. Okay, trying to heat and stir until no longer dissolve. What is no longer dissolve? Okay, no longer dissolve meaning very simple. No longer dissolve. Meaning, okay, all of the acid are already reacted with copper 2 oxide. Okay, all of the acid already reacted to copper 2 oxide. Meaning, all of the acid already used up. Okay, completely used up. So that you don't have any reaction anymore. The copper 2 oxide also cannot dissolve anymore because the acid already finished. Okay, all of them become already copper 2 nitrate. Okay, that's why when the become copper 2 nitrate, so when the copper 4, so surely you get extra, you get excess, you get extra powder inside the copper nitrate. Okay, so what happens is you have to take out the extra copper dioxide. Okay, this is the fourth process is the unreacted copper dioxide. Okay, which is not reacted because already filtered. Okay, correct. You need to filter. Okay, filter out the copper dioxide. Okay, which is you don't want. Okay, extra one. Then you want your copper nitrate. That's when your copper nitrate your soluble salt. Okay, but you still not get your pure salt. It's still soluble. You still cannot see the salt. Same thing lah. So the behind steps all are the same as soluble spark salt. Okay, so you need to heat. Okay, heat, cool, filter, rinse, dry. Okay, same step as just how you prepare for the soluble spark salt. Okay, soluble salt, the behind 5 steps. That's why you need to do. Okay, heat, cool, filter, rinse, dry. So that you get your crystal salt. Okay, crystal pure salt. So for those who just join, maybe if you miss the fun part, okay, you can just watch the YouTube later, okay? We upload the YouTube later, okay? Okay, so any problem? Okay, okay, no problem. This one is some of the discussion, okay? And the equation, all that, okay? This one you can try to read yourself, okay? So if you don't understand question, you just ask me, okay? Ask me what's your whatever, okay? So and this is the experimental steps, okay? So how to prepare soluble salt, okay? So you can try to read through, okay? I just explain it. If you don't understand, just ask me, okay? When you try to recall back whatever later in future, okay? So last one is to prepare insoluble salt, okay? Insoluble salt. Now, insoluble salt, you got the name. They always ask, by the way, okay? What is the reaction? What is the name of the reaction that prepare insoluble salt? Now, this name is called double decomposition reaction. Okay, double decomposition reaction. Okay, where they will prepare uh, 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 insoluble salt. Okay, insoluble salt. Now let's look at it, how to prepare. Okay, page 9. Sorry, page 8. Page 8. Okay, okay. For example, BaSO4 is BaSO4. Okay, ask yourself, soluble or insoluble? Okay, it's insoluble. Sulfate all soluble except PbBaCa. Okay, see remember? Okay, so now BaSO4 insoluble is the balik. Insoluble you can use what to prepare? You can use soluble to prepare. Terbalik. Because that's how to prepare soluble, you need insoluble salt. For now, soluble salt, insoluble salt, you need soluble salt to prepare. Okay. What are the soluble salt? Spun. That's when you remember this one. Okay. Spun salt can prepare insoluble salt. Okay. So first chemical we can use what? First chemical you use, okay? SPA, sodium, potassium, ammonium, okay? Either one, okay? Sodium means sodium sulfate also can, potassium sulfate also can, ammonium sulfate also can, okay? Second chemical is barium nitrate, okay? Barium nitrate also can prepare BaSO4, okay? Now, sometimes not only nitrates available, okay? Span stand for what? Span stand for sodium, potassium, ammonium, N stand for NO3 negative, okay? So, not sometimes it's not only nitrate is available, okay? Some tricky question, they also come out with Cl also possible, SO4 also possible, okay? Because some of them might be possible, okay? So, other than Ba nitrate, sometimes Ba chloride, barium chloride also can. Barium chloride is also soluble, okay? Now, but of course, in this case, you cannot get sulfate. Why? Because you want to prepare sulfate, barium sulfate, takkan you have barium sulfate, okay? Doesn't make sense, okay? By the way, it's insoluble, correct? Okay, it's insoluble. So, if you want to prepare BaSO4, means you don't have BaSO4, okay? So, takkan you got BaSO4 suddenly, okay? So, it's why, in this case, you only got either use Ba nitrate or BaCl, okay? In certain cases, like for example, if you want to prepare magnesium carbonate, okay? This when the choices is a lot, okay? Soluble, yes, correct. Some of the objective questions also I saw like they ask which one can prepare BaSO4? They will give some choices, soluble or insoluble, soluble or soluble, insoluble. They give some answer, okay? So for example, if I want to prepare MgCO3, okay, I use span, okay. First, either I can use sodium, potassium, or ammonium carbonate, okay. So second, I can either got magnesium nitrate or magnesium chloride acceptable because magnesium chloride also soluble. Okay, something you can consider. But if you cannot consider means insoluble. Okay. Third one is sulfates. Okay. Magnesium sulfate, magnesium chloride, magnesium nitrate, also soluble. Okay. So in this case, for the special part, okay. But normally you got nitrate because nitrate is the safest one, safest option. Because nitrate is all soluble. Okay. So you got sodium sulfate react with all the barium nitrate, okay, to produce barium sulfate. Okay. Now, how to prepare experimental steps? Okay. So reason, okay, okay, reason very simple. Okay. So first of all, put this amount of sodium sulfate inside using measuring cylinder, okay, and pour into the beaker. Pour into the beaker, okay. After that, you got two soluble. You just prepare something, okay, for sodium sulfate, for barium chloride. Okay, barium chloride or barium nitrate, okay. So you pour inside into the same beaker, same amount, same beaker, okay, same amount and same beaker, just different chemical, okay. After that, you try to stir. Use glass rod to stir, okay. Glass rod to stir. Glass rod look like this, okay. Uh, something is made by glass one, okay. Try to stir. Then, because you form insoluble salt, right? So if I insoluble salt, you can see the white precipitate, okay. Your white precipitate inside the beaker, okay. Now, since you can see the white precipitate, right? So you no need to do heat pull, okay. You straight away can filter out already. Okay, you no need to force the stop up, okay. So that's why on the bottom you don't have heat pull, okay. You only need to filter, rinse dry enough, okay. You straight away can filter the white precipitate out. So then after you rinse it, then you get your, after drying, you get your insoluble salt straight away, okay. So you skip the heat and pull. You just filter, rinse dry. There's enough, okay. So any problem? Okay. So move on. Okay. So now this is some of the equation, okay? Equation and also the discussion, okay? You can try to read through that, okay? And This is the experimental steps and the including the equation. Okay. Also, you can try to read through it. Okay. So if you have any problem, okay, you can ask me now later on. Okay. After reading this or trying to do revision. Okay. So move on. Any problem? For preparing salt, so you got 3 types. Okay. I sum up. First, you prepare soluble spa salt where you're using neutralization reaction. Okay. You got acid and alkali. Second, you prepare soluble non-spa salt where you use as an acid and also an insoluble salt. Third, okay, you prepare insoluble salt. Okay, insoluble salt meaning, okay, you got using 2 soluble salt to prepare. Okay, so no problem. If no problem, then move on already to the next part. Okay, next part I believe is color. Okay, now okay, I'm sure some of you still don't remember the color. Okay, but don't worry. Okay, I will teach you some of the important one. Okay, but color of course okay. I use 2 hours, you can not remember everything. Okay, so that's why you have to do your own revision and also the color block. The question that you cannot finish in class whatever. You can try to do your own. Okay, so example here. Okay, you got important one. Okay, Fe2 plus always green, basic one. Okay, Fe3 plus always brown, doesn't matter. Okay, doesn't matter pairing with which anion, it will always get the same color. Okay, Fe2 plus green, Fe3 plus brown. I'm sure also repeated many times in Form 5 Chapter 1. Okay. After that, you got CO2 plus. Okay. CO2 plus mostly the solution is blue color. Okay. Copper to sulfate solution blue. Copper to nitrate blue. Copper to hydroxide blue. Okay. Copper to chloride aqueous also blue. Okay. Also blue. Okay. Except steel. Okay. Copper to carbonate. Okay. Copper to carbonate is green. Okay, it's green. Copper to chloride, where it is solid, also green. Okay, green up. This two green up. Okay, and one more special one. Copper to oxide is black color. Okay, black color. Okay, other than that, all are white color salt. Okay, other than that, all are white color salt. Okay, and also the special salt. You remember? Okay, not sure if you still remember this or not. Okay, so don't worry, you can recall on time. Okay, so PBO PBO brown when hot, okay, yellow when cold. Brown when hot, yellow when cold, okay. PBO, lead to oxide, okay. So this one is, you can remember as your peanut, okay. Peanut, okay. Peanut outside the skin is brown color. When you open up the skin, inside is yellow color, okay. So PBO, you can remember as peanut, okay. ZNO, ZNO is yellow when hot, okay. White when cold. This one you can assume as a banana, okay. And banana skin outside is yellow, open up inside is more to white color. Okay, this one is your ZNO. Okay, zinc oxide. Now this one student always confused. Okay, which one is PBO, which one is brown, which one is yellow, which one is white. Okay, so PBO brown when hot, yellow when cold. ZNO yellow when hot, white when cold. Okay, for PbCl2 insoluble in cold water. Okay, when it's cold it's insoluble, meaning you can see the precipitate inside. You can see the white precipitate inside. Okay, when it's cold, when you're trying to heat up, what happens? When you're trying to heat up, it's soluble already. Okay, it's soluble already. Means you couldn't see the white precipitate anymore. Okay, anymore. This is okay. Same for PbI2. Okay, PbI2, but PbI2 is yellow color. Okay, yellow precipitate. Okay, so when it's cold, you can see. After you heat up, you get soluble. You dissolve inside, you couldn't see the salt anymore. Okay, but when you're trying to cool down, then you can see the soluble salt. You can see the precipitate again. Okay, PbI2 special case, there is also insoluble salt. Yes, consider it's insoluble. Yeah, consider it's insoluble. PbCl2 insoluble, PbI2 insoluble. Only special case when they say, okay, you heat up, then you dissolve inside. Okay, temporarily you heat up, then you can get soluble salt. Okay, but not in general you consider as insoluble. Okay, so it's okay. Now the colors, okay, the color, okay, this one I talk about, okay, color Fe2 plus green, okay, Fe3 plus brown, okay, COSO4 is, cause if normally if paired with COH, then it's normally considered as insoluble. Yeah, it's insoluble. You mean like Pb paired with COH? All of the salt paired with COH is insoluble. PBI, PSI or PBI means what? Pair with iodine. Oh, pair with iodine. Yeah, it's insoluble actually. In normal temperature, it's all insoluble. Okay, only if you try to heat up when it become hot, then it's temporarily soluble. When it cool down again, then you see the precipitate again. You see the insoluble salt again. Okay, PbI2, PbCl2, PbBr2 same. Okay, so okay. Move on. Okay, Fe2 plus green, Fe3 plus brown. Okay, then after that you got uh after that CuSO4, Cu nitrate, all blue color. Okay, or most of the copper 2 solution are blue color. Okay, after that you got copper 2 chloride. Okay, copper 2 chloride is when in solid state is green. When you are in aqueous solution state, is blue color. Okay, means you add water, you become blue color. Okay, after that, copper 2 carbonate is insoluble. So you find insoluble in water. Okay, so you cannot dissolve in water, so always green color. Okay, so here are the few examples. Okay, if I give you a green color solid, which salt is possible? Okay, so by doing few tests, okay, for example, when you cannot dissolve in water, okay, and you can see green color, okay, automatically qualify as copper 2 carbonate. Okay, and if you can dissolve in water, then normally yes, Fe2 plus salt. Okay, Fe2 plus salt doesn't matter pair with, as long as pair with soluble salt. Okay, for solid X, okay, for the other side is when you can dissolve, then you can see blue color solution. That is copper 2 or copper 2 chloride. Okay, from green solid become blue solution. That is copper 2 chloride. Okay, so any problem? Okay, color lah. Talk about color. Color shouldn't be a problem. I mean, Fe2 plus simple lah. Except for copper 2 lah. Okay, and also the special salt like these two. Normally shouldn't forget lah. Okay, move on. It's okay. Color no problem. Color no problem. Then we move on to heating area. Heating also very simple. Okay, heating you only got like few. You only got two heating, two ion. Number one, heating. Okay, heating you heat carbonate. Okay, number two, you heat nitrate. That's all for heating. Okay, only got two ion. But you remember, okay, heating carbonate, heating nitrate. Okay, but also you need to know what they come out. Okay, what are the products? Example, when I heat carbonate, I will get carbon dioxide. Yes, this is a certain one. Okay, so carbon dioxide. How to test carbon dioxide? Sometimes they give, they won't give carbon dioxide. Sometimes they give, also they won't give carbonate. Usually you give lime water turn cloudy. What is that? What's the gas? So you know it's carbon dioxide gas. Okay, either milky or cloudy or chalky. Okay, all are the same lah. Milky, cloudy or chalky, all are pointing towards carbon dioxide. Okay, so carbonate will produce, okay, carbon dioxide for sure. For nitrate, you produce, for carbonate, you produce one gas only. For nitrate, you produce two gases. What are the two gases? You produce nitrogen dioxide, okay, and oxygen gas. Okay, oxygen gas. But for carbon dioxide and oxygen gas, you don't have color, you form colorless gas. Okay, colorless gas. So how do we test oxygen? Oxygen, okay, lower the glowing wooden splitter into the test tube. Okay, so you put the splitter test tube inside. Okay, after that, the glowing splitter is relighted. So you got flame. Okay, you got either relighted, you can say rekindle also can, or reignited also can. Okay, either one. Okay, after that, for nitrogen dioxide, now nitrogen dioxide got color, what color? Brown color. Okay, got brown color gas come out. Okay, so and also nitrogen dioxide is an acidic gas. Okay, so that's why you turn blue color litmus paper become red color. Okay, become red color, and also you got pungent smell, quite very smelly, okay, quite smelly like your fish, your uncooked fish, something like that. Okay, your spoiled fish, something like that. Okay, so very smelly, pungent smell. Okay, this one is all nitrogen dioxide. Okay, so these are the differences. Okay, but for the common things, for the similarities, both when you heat the salt, let's say you see zinc carbonate, lead 2 carbonate, magnesium carbonate, calcium carbonate, and copper 2 carbonate. Okay, there's one certain thing will come out. Okay, the common thing is both will come out oxide salt. I mean solid, not salt. Oxide solid. Okay, this is a common thing between them. Okay, you come out oxide. Okay, so let's go through the simple one. Okay, so for example, I ask you, when I heat zinc carbonate, what will come out? So carbonate, there's one certain thing that you come out carbon dioxide and also zinc oxide. Like this one. Okay, or same thing, MgCO3. Okay, when I try to heat, I come out MgO and also carbon dioxide. Just like this. Okay, I think the heating part is should be considered as easy. Okay, and also, okay, the other one is let's say I heat copper 2 nitrate. Okay, what do you come out? I come out three things. For this, you got three things. Okay, what are the three things? Okay, very good answer. Okay, so CO plus NO2 plus O2. Okay, that's one time. Okay, if I got uh let's say Mg nitrates, I hit, what do I come out? Okay, I come out MgO, okay, NO2 and O2. Same thing, okay. It's just that when you have different metal, then you get different metal after the reaction. Okay, so okay. That's not heating. Okay, that's not heating. But of course, you need to do the test. Okay, later on you do some question. Okay, move on. This is a case study, gas test. Okay, so the gas test you got eight. I think here you got eight. Okay, so common one, of course, like carbon dioxide, no one. Bubble the gas through lime water turn cloudy. Okay, and also hydrogen gas. Hydrogen gas is like a pop sound. Okay, you put same thing, similar to oxygen. It's just an oxidation different. Okay, for hydrogen you got pop sound. For oxygen you got rekindle. Okay, relighted for glowing wooden splinter. Okay, then all the chlorine you can try to read yourself. Okay, so and also ammonia. What's the test? Ammonia is alkaline, but so that's why the litmus paper become blue color. For hydrochloric acid, for nitrogen dioxide, you got brown color gas, then the litmus paper become red color because it's acidic gas. Okay, and so on. Okay, so any problem? So this the I gotta go through. Okay, so move on already. So we move on to the second last part. Okay, so I think one of the most students struggling is anion test and cation test. Okay, so I think I must go through that. Okay, so example. Okay, I got anion test. Okay, anion test. You need to remember four ions. Okay, so you got carbonate. Okay, carbonate, chloride, sulfate, and nitrate. Okay? So first of all, I teach you the simplest one. Okay, let's say I got four test tubes. Okay, so everything first of all, First of all, everything I add what? I add acid. Okay, I add acid. Okay, so after that, add acid. Now, if I got bubble come out, okay, means what? Now, automatically, this is carbonate ion. Okay? Means what gas will come out? You got carbon dioxide gas coming out. Okay, so simple. Okay, here I add acid. I add acid straight away. If the anion, if I got gas release through lime water, meaning you got bubble come out, meaning lime water turn cloudy, meaning is carbon dioxide gas. Means carbon dioxide means you got carbonate, okay? Carbonate ion. The first one, okay? Carbonate ion how to test? We put acid, straight away you got bubble come out, okay? So it's okay. So second and third one, which is a bit complicated, okay? So second, you got chloride. Now, this is when you need to apply your solubility of salt, okay? So you see, remember, chloride is all soluble, okay? So after adding all the acid, no bubble, okay? Of course, everything you have to add acid, okay? For chloride, for sulfate, you also have to add acid, okay? After no bubble, then you test, okay? So you apply the solubility of salt, okay? So for example, okay, Cl minus, okay, all soluble except three, okay, except three. The three I talk about is Pb, Ag, Hg, okay? Pb, Ag, Hg, okay? For the front part, okay? Which is insoluble. Insoluble. So meaning I use one of these to get my Cl minus ion to confirm my Cl minus present. Okay. So means let's say I use normally I use Ag, okay. So that's why I use Ag nitrate for second one. Okay. So that my Ag nitrate, let's say I put example, I add Ag nitrate. Okay. So my let's say inside I got Cl minus, okay. Ag and nitrate. Ag I got Ag NO3 means Ag plus NO3 negative. Okay. So what happens is this Ag plus now you find another partner. This one the partner is NO3 negative. Now my Ag plus is bought. Okay. Trying to find another partner. Okay. Let's say if inside I got Cl minus, right? So I will react with Cl minus. Okay. What do you found? You found AgCl. Okay. By the way, means AgCl means what? Means insoluble. Okay. Insoluble means you got what? You got white precipitate form. Okay. For this case, you for Cl minus ion, how to know that the test tube inside you got Cl minus, you add acid, then if acid don't have bubble, then you add Ag nitrate, okay, so that I will get your AgCl, which is white precipitate. Then confirm the presence of AgCl. Okay, move on. Okay, move on. I got the other one is SO4. SO4 also quite similar. Okay, also applying the solubility of salt. Okay, so same thing. All are soluble. SO4 all are soluble except three. Pb, Ba, Ca. Okay, all are soluble except three. Pb with the mid Pb, Ba, Ca. Okay, so what happens is example I use, okay, I use Ba sulfate. Okay, so not Ba sulfate. I use Ba nitrate. I use a soluble salt so that it can dissolve inside the solution, so that the ion can go and find another ion, so that it form white precipitate. Okay, so in this case is Ba nitrate. Okay, so normally like I can either use Ba nitrate or Ba chloride, same thing only. Okay, so what do we form? It will form. Okay, for example, I draw one more time. Okay, so I add Ba chloride example. Okay, or Ba nitrate or scan. Okay, nitrate is the simplest because nitrate all are soluble. Okay, so what happens is I add inside. Okay, let's say inside got SO42 negative. Okay, So I got Ba2 plus Cl minus. Okay. At the beginning, the Ba2 plus, you got the partner is Cl minus. Okay. After that, you sum inside, you find another partner. Okay. You find SO4 negative. Okay. So therefore, BaSO4, BaSO4 I talked about just now is insoluble salt. Okay. So same thing you got also white precipitate is formed. Okay. White precipitate is formed. Any problem? No problem. Okay. Okay. Yeah. Okay, move on. Very good. Okay. So you got carbonate, Cl minus, and SO2 negative. Okay. Both need to add acid, or all those need to add acid. Okay. After that, carbonate, you got bubble. So you got carbonate. Cl minus and SO2 negative means you need to look at the solubility of salt. Okay. Add AgNO3, BaNO3. Okay. After that, last one. Nah, last one, nitric acid. Nitrate ion. Okay. Nitrate ion, which is also one of the most popular one. Okay. The exam. Okay. So, nitrate ion, you need to remember three shortcuts first. Okay. What are you doing? 1, 2, 3. Okay. Now, you remember SO4, 3SO4. Okay. You remember 3SO4. Okay. After that, okay. For first, second, third. Okay. So you got first on top, at the bottom, you got H2SO4. Okay. The first one is dilute. H2SO4. Dilute means you normally contain more water lah. Okay. More water, not so concentrated. Okay. But for the other one is concentrated sulfuric acid, means very thick lah. Okay. Very thick, a lot of H2SO4 inside. Okay. Less water. The second one is FeSO4. Okay. Iron 2 sulfate. Okay. For the first and the last is you add sulfuric acid. Okay. Either it's dilute or concentrated. Okay. For the middle one, you add iron 2 sulfate. Okay. Now, after that, how much need to be added? Okay. So first two, you add 2 cm cube. Okay. 2 cm cube. Okay. For the last one is you put few drops only. Since it's already very thick, right? So you don't need to put so much. Okay. It's already very concentrated. Okay. So you only put few drops in. Okay. So this structure. Okay. So H2S4, FeSO4, H2S4. Okay. This shortcut. At the right, you also got shortcut for this. Okay. For this part. Okay. So any problem? Now, I explain a bit. Okay. So the steps. Now, the steps are always in the exam, always asked. Okay. So first of all, you add what? You add 2 cm of dilute sulfuric acid. Okay. Your dilute H2S4, followed by cm of iron 2 sulfate solution. Then you shake well. Okay. Shake well. Then after that, what happen? A few drops of concentrated sulfuric acid added slowly down the wall of slanted test tube. What I mean by slanted test tube? Slanted means you trying to make it not upright. Okay. Terbalik. Not everything going down. Okay. It's like 45 degrees Celsius. Okay. Celsius plus 45 degrees angle. Okay. Then you try to put few drops of concentrated sulfuric acid. Okay. After that, you turn the test tube upright slowly. Okay. Then now you don't treat the test tube. Okay. What's the product form? Now you got brown ring form for nitric ion. Remember? Brown ring. Okay. Brown ring. Okay. So maybe you ask me why I purposely slanted my test tube. Okay. Make my test tube slanted. Okay. Reason very simple. Okay. So if you don't put slanted, when you add concentrated sulfuric acid, so at the brown ring, all the acid you form will be at the bottom. Okay. Means my brown ring now you go to bottom, which is very hard to see. Sometimes will not be formed. Okay. So to make sure everything is concentrated in the middle. Okay. I make the test tube become slanted. Okay. So my brown ring form also will be in the middle. Okay. So it's okay. This one is nitrate. Why shake? Don't show also. I mean, Sure also can. I mean shade in this case you can shade. Okay, shade a bit, okay. Not to shade so much, okay. Just shade a bit, then enough already. Okay. Not sure. Okay. In this case, shade is better. Okay. Okay. Or you can this simple this one you can use your stopper also can. You stopper, you can close the stopper, okay. Then you shade off, okay. For the one not easy one, the one is a bit harder, okay. After that, this one, okay. This is a 4 and test. Any problem? Okay, important. Okay, last part, cat test. Okay, cat test a bit harder. Okay, cat test you got a lot of things. Okay, cat test number one part. Okay, PB2 bus. First of all, PB2 bus. Okay, PB2 bus how to test? You put Ki. Okay, potassium iodide. Okay, Ki you contain these two ions, K plus and I minus. Okay, so that I minus we find PB2 plus. Okay, what do we form? We form PbI2. You remember just now I talked about PbI2? PbI2 is actually what color? Okay, PbI2 is yellow color. Okay, so that's why you got PbI2 yellow precipitate form. Okay, this is first part. You add 2 cm of potassium iodide into this test tube. Okay, then you got yellow precipitate form. Okay, second you got NH4 plus. NH4 plus is ammonium ion. Okay, ammonium ion you add Nestle reagent. Okay, Nestle reagent. Okay, so Nestle is like look like a Nestle, okay? You're drinking Nestle, okay? Also similar to a Milo color, okay? Now, so that's why your final part, what color you form? You get brown. Okay, this one get yellow, this one get brown, okay? After you add few drops of Nestle reagent, then you get brown precipitate form, okay? Now, notice normally if you don't know the chemical, right, means the chemical is very expensive. You don't know the chemical formula, means this one unknown, right? Normally not familiar to you, right? So you only add few drops enough. Let's say if you know, right? If you know potassium iodide, you know very clear, okay? So that's why you add 2 cm cube like this, okay? So this is for PB2 plus, you add potassium iodide, you get yellow precipitate. For NH4 plus, you add Nestle reagent, you get brown precipitate, okay? After you got Fe2 plus, Fe2 plus is you add, remember this one? Add few drops of potassium hexacyanophthalate solution, then you get dark blue precipitate, okay? I believe in form 1 chapter 1 also repeated for this, okay? You repeated for the rusting of iron, okay, you iron nail, inside you put phenolphthalein and all the potassium hexacyanophthalate, okay? If you still remember, okay? If you still remember, okay? So you add this potassium hexacyanophthalate, okay? So you get your dark blue precipitate form, okay? For Fe, then you confirm the presence of Fe2 plus, okay? Fe3 plus, you add, now either you can add few drops of potassium hexacyanophthalate 2, okay? Means 2 plus you add 3, 3 plus you add 2. So both you also have dark blue precipitate form, okay? But of course for Fe2 plus, you got another option, which is you also have potassium thiocyanate solution, okay? So you get the blood red solution, okay? These few choices these few ion cat ion no choice you have to remember your own, okay? Then for Cu plus, you add ammonia, okay? Ammonia in excess, okay? What about this? First, I got blue precipitate form. After that, I dissolve in excess ammonia solution. You get dark blue solution, okay? We dissolve. You add some more excess extra ammonia. All of them dissolve. You get blue solution, dark blue solution, okay? This for Cu2 plus over 2 ion, okay? Ammonia, I add ammonia, NH3, okay? Any problem? Last part, move on, okay? So for cation test 2, okay? Now this one I confirm you the color first, okay? For field bus also this one I talk about I add energy ammonia, okay? So first of all I got blue precipitate. If I add excess extra, then all of them will dissolve. form dark blue solution. Okay. Fe2 plus, you gonna test, you also can do NaOH, NH3 also, then you get your green precipitate. Fe3 plus, you add these two, you also get brown. Okay, brown precipitate. So any problem? Okay. The problem with you is this. Okay. The problem with you is this. Okay. Most students don't remember this. Okay, how? Okay. I teach you a method to remember, okay? So okay, so you got ZCM. Okay. So what happens is you remember the ZCM as well. ZCMS. Wait, ZCM. Okay. You remember as subchip small, I don't know. If you know Cantonese like sub Cao Min or something, okay, or so like anything like okay, as long as you can remember, okay, ZCM, okay. By the way, what is ZCM stand for? Okay, ZCM stand for Z stand for what? Z stand for what? Z stand for zinc ion. A stand for aluminum ion. P stand for lead-2 ion. C stand for calcium ion. M stand for magnesium ion. Okay. After that, now you need to remember add three things. First is you add NaOH, then you add excess extra. Okay. After that, you add NH3. Also, you add excess. Okay. Third, you add Ki. Okay, Ki. So you have to remember this four. Okay. You got first of all you got W. Okay. Then you split the Z and AP. Okay. You split Z and AP, then you got add another W. Okay. After that, then you split the C and M. Okay. You add NW. Then you split the A and T finally. Then you got N Y. Okay. Now how to remember? You remember ZCM. Okay. First you add NaOH. Okay. Second you add NH3. Third you get Ki. Okay. So you remember WW, your website www 4W. Okay. You just select one more W. Okay. After that you got NW. You can remember many ways to remember. New wing or whatever. Okay. New wing. What else? The word country Norway also can. Okay. And this one remember as New Year. Okay. Or New York. Okay. As long as you can remember easy one. Okay. So WW Norway New York or New Wing New Year. Okay. Whatever. Okay. So after that you add the T. Okay. Add the T into this. Okay. Means WP means what? WP means white precipitate. NP means no precipitate, means it can dissolve. YP means yellow precipitate. Okay. So after that, you add one more thing. You add tick cross, tick cross, tick cross, tick cross. Means soluble, can dissolve. Cross means insoluble, cannot dissolve. Okay. Yeah, no problem. Any problem? So that's why I ask you an example. Okay. How to determine the N2 plus? I normally add ammonia. Okay. When I add ammonia, if I got white precipitate that can dissolve in water in excess, water in dissolve in ammonia in excess means I confirm the presence of Zn2 plus. Okay. If I want to confirm Pb2 plus, very simple. Pb2 plus, the main key is I got yellow precipitate. That's how I talk about when I add Ki. So that I minus can find Pb2 plus, can form Pbi2. Okay. And also, let's say Mg2 plus. Okay, Mg2 plus, when I add NaOH, the white precipitate insoluble. Then, and when I add NH3, also white precipitate insoluble. Okay. So that's why I get Mg2 plus. Okay. This one important. Okay, this is your anion test for half. So any problem? Try out already. Okay, can I? Can I? Okay, so that's it lah. Okay, for the anion test. Okay, any problem? Quickly you do some exercise. Okay, so today I might explain a bit because I need to do an exercise. Okay, so if you don't mind, we'll explain a bit. Okay, so because I think enough time. Okay, so you can look at page 17. Okay, so I don't one more time about the ZCM. Okay, one more time. Then split them. Okay, then first one I got add NaOH in excess. I add NH3 ammonia in excess. I add Ki, potassium iodide. Can try to repeat now. Okay, after that you got split. I mean not split first. W. Then you split the Z and AP. Okay, W. Then you split the CM. Norway. Okay, then split again. New York. Okay, then you add all the precipitate P. Okay, then I do what? T cross, T cross, T cross, T cross. Okay, then you get this table. Okay, so after that, then you can look at this. Okay, so first of all, you solve the curve first. Okay, you are adding NaOH, this question. Okay, NaOH and also ammonia, NH3. Okay, first of all, A and C got color, right? So you settle the color first. Okay, so you got blue color, blue precipitate, blue precipitate. Then you got green, 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 green. Okay, may I know what is A? What is blue? Blue should be Du2 plus. Okay, for bentuk ion. What about green? Normally, what's color? Green. Yes, Fe2 plus. Okay, so I got Fe2 plus. These two factors. Okay, if I got brown, then it's Fe3 plus. Okay, so after that, the BDE to confirm. Okay, BDE now. B white precipitate soluble in excess. White precipitate soluble in excess when I add NaOH. Okay, so this one is three possible. I got zinc, aluminum, lead, so I cannot get the exact answer yet. Okay, but again, when I add NH3, add second time. Okay, so I got white precipitate thick soluble also. Okay, so second time white precipitate thick. Only one possible, which is zinc. Okay, which is zinc ion. Okay, white precipitate NH3 only got one possible. Okay, which is NH3. Okay, then D how soluble in excess. Same thing, white precipitate soluble in excess. Okay, means I got three possible. Then when I add NH3, white precipitate insoluble. Okay, I got two possible for ammonia when white precipitate insoluble. Okay, I got another two possible, which is Al3 plus or Pb plus. Haven't been confirmed yet. Okay, how to confirm? By adding Kl, so that I can split them. Okay, so after that you got E. E is white precipitate insoluble. How? Means either calcium or magnesium lah. Okay, after that I add NH3. Then how? White precipitate insoluble. The only possible is magnesium ion. Okay, so you can write down answer for A, B, C, E. Okay, take another test to identify C. How other than this NH3 NaOH, how to remember what to add? What test? Very long name one. This one. Very long name one. Surely don't remember one. This one is okay. First of all, when you write the answer, right, you need to write what you need to add what you need to test first. Like solution C, right? You need to put solution C inside your test tube first. Okay. If not, they assume inside the test tube is empty. Okay. So if empty, you still will add the thing, add the chemical, right? When you try to test, right, there's no reaction. Okay. So put the thing that you want to test first. Okay. Then after that, you see remember the potassium hexacyanophyllite 3 solution. Okay. Few drops will add inside. Then after that, you got dark blue precipitate is formed. Okay. I read out first. Okay. Okay. C. What are the possible cation present in solution D? This one is your aluminum ion and lead 2 ion. Okay. But how do I separate them then? If there are two possible, I need to break them into one. Okay. So that's why the possible is I add Ki to differentiate them. Okay. So that first of all, of course, I add solution D into the test tube. Then I put Ki inside. Okay. All these 2 cm, you write 2 cm. Normally I put 2 cm cube. Okay. I put solution D inside. Okay. Then I got potassium iodide solution. Okay. Then got two possible. If I got yellow precipitate means what? Means confirm is lead 2 ion. Okay, Tb2 plus. I got yellow precipitate. Okay, means lead 2 ion form inside the present inside the test tube. Okay, if I got no change, no precipitate, nothing happen. Means what? Means confirm that this is aluminum ion. Okay. So any question? Okay. Yeah. Finish. Okay, done. For those who haven't, then just screenshot. Okay. So after that, you can look at next question. Okay. So no. Okay. Move on. Question. One discussion. Okay. Okay. Question 11. Okay. So page 18. Okay. Okay. So test one. So add sodium hydroxide. Okay. White precipitate. Test two. Ammonium solution. Okay. White precipitate form. Test three. I add potassium iodide. Keyword. Okay. And I got yellow precipitate form. What is the ion? This one very simple. Okay. I got yellow precipitate when I add Ki. The only possible is lead 2 ion. Okay. Lead 2 ion. Test 3 important. What is test 3? test 3 to confirm the presence of that two ion. Okay. If sodium chloride is added into the water, state of solution, explain answer. Okay. Sodium chloride get added into water. Okay. I put NaCl. What happened? Okay. So I got white precipitate form. Okay. Why? Now, in case I put Ki, let's say I put NaCl. What happened? NaCl into this Pb2 plus. Okay. So Pb2 plus we find Cl minus 1. We form PbCl2. Okay. Remember I talked about PbCl2 just now. Okay. Similar to PbI2. Okay. Where you heat. Okay. When you heat, the precipitate will dissolve. Okay. It will be soluble. When you cool down, the precipitate will reappear again. Okay. Same thing to PbI2. Okay. But PbI2 is yellow. PbCl2 is white color. Okay. Actually, I also can add NaCl. No problem. And KCl, NaCl, Ki to confirm the presence of lead 2 ion. Okay. Now, normally we do Ki. Okay. How to remove? Okay, this one very simple. Okay. So let's say NaCl. NaCl. Okay. Um, let's ask, how do I remove ion in air in drinking water? Very simple. Okay. So the reason I add this I add sodium chloride because when I add sodium chloride, okay, sodium chloride uh react with another soluble salt, right? So what happens is I form PbCl2. Okay, PbCl2 is your insoluble salt. Okay, insoluble salt we form from two soluble salt. Okay, so that's why what happens is insoluble salt you have white precipitate. Okay, this white precipitate uh you can be filtered out. It can be filtered out. Okay, after filtering out then you get your clean water, get your pure water. Okay, let's say inside the water I got contain PbCl2. Okay, how do I remove it? Okay, contain of Pb2 plus. Okay, so I put NaCl. Okay, so that the Cl can take the Pb out together. Okay, 24. Okay, right now first. Okay, okay. After do another question. Okay, move on. Okay, done. Okay, okay. Move on. Question 12. Okay, page 19. Okay. So now this one you need to recognize the color of salt. Okay. So first of all, if I ask you, who still remember what is black solid? Oh, the only one chemical, black color solid. Not sure. Who remember black solid? The only possible copper 2 oxide. Okay. Copper 2 oxide. Normally copper is blue color, I know. Blue color solution. Okay, copper 2 nitrate, copper 2 sulfate, all blue color. Okay. Some of it a bit of green color. Okay. Except one that's black color solid is copper 2 oxide. Okay. So what about brown gas? Who remember brown gas? Okay. When you heat the salt, right? You got black solid, you got one brown color gas, one no color gas. Okay, very good. So finally you got NO2, okay, nitrogen dioxide. Then you got the pair which is oxygen. Okay. So now this also indicate what? What is the salt X? Okay. So you got copper, right? So surely got copper 2 ion. Okay. So I got NO2 and O2. Means what is the ion? I use what's the ion here? The ion here is NO3 negative. Okay, nitrate ion. Okay. So my salt is actually copper 2 nitrate. Okay. So sometimes you can figure out through this. Okay. So after that, I add water. Okay. I add water. Do you think I add water? Do you think got any difference? Okay. Let's say this is actually at the beginning is a solid in solid state. Okay. Just like a Milo powder example. Your Milo powder is in solid form. Okay. When I add water, normal water, do you think it becomes another chemical? Another thing? No, right? Started Milo won't suddenly become Horlicks. Okay. Okay. So very funny. Okay. Normal water only. Water, just like no water. Okay. So Milo powder, you add water, it become Milo, Milo powder, it become Milo water. Okay. So means actually blue solution one is also copper 2 nitrate. Okay. So some of the student might be tricked. Okay. So they're thinking a lot of things. Okay. Actually nothing happened. Okay. Copper 2 nitrate, add water, copper 2 nitrate. Okay. One in solid state, one in solution state. Okay. Aqueous state. After that, you add sodium hydroxide, NaOH. One, you add ammonia, NH3. Okay. So what happens is these two states you very familiar. So you will get a blue precipitate, okay, blue color, because you got copper 2 ion. Okay. So means all these two actually is alkaline. Means you got OH minus. Okay. So basically what happens is means you got OH minus. So for this blue precipitate, you got copper 2 hydroxide. Okay, copper 2 hydroxide. After you add excess amount, then for ammonia wise, you dissolve. Okay, dissolve it become dark blue solution. Okay, so you can write the answer. For black solid, P is copper 2 oxide. Brown gas is nitrogen dioxide. Gas, colorless gas R is oxygen gas. For blue solution, Y is copper 2 nitrate. Okay. Okay, B, chemical equation to represent the decomposition of salt X by heat. Okay, so means you trying to heat trying to heat copper 2 nitrate. Okay, equation heat. Okay, after that become copper 2 oxide, nitrogen dioxide, oxygen gas. Okay, but if you leave like this for your answer, you get 0 marks. Okay, because you don't balance. Okay, so you need to balance the equation. Okay, so balance equation. Okay, so you notice n okay, so n you got 2 okay, so you times 2 but the problem is for O. Okay, for O you got 6O here. Okay, here you got 1O, 2 times 2 is 4, 2 here. So 1 plus 2 plus 1 plus 4, sorry. 1 plus 4 plus 2 is 7. Okay, but here you got 6. So how? You start with one even number, one odd number. Okay, so how? When you start this in this situation, okay, so you times the longest chemical formula times 2. Okay, which one is longest chemical formula? Okay, supposed to be Cu nitrate. Okay, times 2. Okay, after that, now copper I got 2 also, so you times 2 for CuO. Okay, now N how much? N is 2 times 2 is 4. Okay, so I got 4NO2 here. Then you calculate the O. Okay, now you got 2 times 3 times 2 is 12. Okay, now I got 2 plus 4 times 2 is 8 plus 2 is 12. Okay, so any problem? Yeah, no problem. Okay, very good. Okay, so after that, okay, explain briefly how you confirm the anion presence of salt X. Okay, so first of all, NO3 negative. Okay, important this question. Salt X is copper nitrogen. The N ion is negative ion. N ion is negative ion. Cat ion is positive ion. Okay, so they ask for NO3 negative N ion. Okay, negative ion. So the test, remember, you got shortcut. You got 3s4. Okay, so you got top and bottom is H2s4. Top is dilute. The other one is concentrated. Okay, so middle is FeS4. So first two you got 2 cm3. Okay, last one you add few drops is enough. Okay, so first step, of course, before everything else, you have to add the things that you want to test. Okay, which is solution Y. Okay, because inside itself contain got and nitrate ion. Okay, if you don't add solution Y, of course, inside you don't have test tube you don't have nitrate ion. Okay, that is pointless if you don't add. Okay, after that, okay, you add solution Y. Okay, then you add dilute sulfuric acid. Okay, iron 2 sulfate solution. Okay, after that, you shake the mixture, then followed by a few drops of concentrated sulfuric acid. Okay, then adding slowly, okay, add slowly into the slanted test tube. Okay, finally, what form? What do you see? Brown coloring. Remember, brown coloring form. You got brown coloring form. Okay, can you first? School holiday, do you go anywhere? Or you got a lot of extra class? I heard some of the students told me, oh, exam being bring forward. Oh yeah. So you're very focused on exam. I still know some people travel, okay, but or go other places, okay. But most of you, I think, left half a year, okay. Don't have much time. I understand also. Okay, so that's why a bit tight lah. As I said, study also lah, okay. Okay, after that, any problem? Okay, okay, for D, okay. So, I give you 1 more minute, okay. Okay, so any problem? Okay, okay, last part. Okay, uh, a black solid P can be changed into salt X through reaction W. Okay, suggest a chemical that is suitable for changing the black solid back to salt X. Okay, so now this question is a bit tricky. Okay, not to say tricky, but normally you don't realize. Okay, so example okay, so uh they ask how do I change this go back to this now means very simple. They ask meaning they ask how do I prepare this salt? This meaning word prepare they realize. Okay, so now how? Okay, so let's say I want to prepare copper to nitrate. First of all, ask yourself, is this soluble or insoluble? Okay, of course it's soluble. Okay, nitrate salt all are soluble. Okay, all are soluble. Okay, so if it's soluble salt you need to use insoluble to prepare. Okay, which is your COOH still remember the method. Okay, so and also if you just put inside water, nothing will work. Okay, so you put inside acid. Okay, then it will work. Okay, so after that, okay, first chemical which you already got, which is copper 2 oxide, which is here already, which is already given. Okay, so the second chemical is nitric acid, HNO3. Okay, nitric acid. These two chemical can get your copper nitrate. Okay, so they ask what such a chemical that is suitable for changing the black solid P to salt X. You need to add nitric acid. Okay, so by the way, don't copy. Okay, this one you can just screenshot or you can find the answer in the QR code at the page 1. Okay, so I gotta explain. Okay, so basically you add acid, then you add the black solid P using a spatula, just pour inside. Okay, until it no longer dissolve. Okay, you stir. Then after that, what you do is you filter the excess black solid out of the mixture. Okay, then you get your copper nitrate. Then you heat, cool, filter, rinse, dry. Since this is an soluble salt. Okay, so you need to heat, cool. Okay, to get the crystal salt out. Okay, after that you filter, rinse, dry the crystal salt. Okay, so you can go back and slowly write down. Okay, so I give you a few seconds to screenshot. Okay, whatever. Okay, so after that move on to another question. Okay, okay, done. Okay, move on. Okay, so we got another question, question 13. Okay, so in this case, example. Okay, uh, first of all, okay, they want to heat. Okay, took place. Okay, solid N they told you is a zinc salt. Means you got what? You got Zn2 plus confirm already. Okay, but you don't know what it's ion. But you don't. Why? Very simple. They ask when solid M is heated. Okay, you get yellow when hot, white when cold. Okay, what is solid Q then? Solid Q is yellow when hot, white when cold. This is only one and the only thing, oxide. Okay, you got two things to confirm. Number one, you're heating the salt. Heating the salt confirm you got zinc oxide. Okay. Second, you got yellow when hot, white when cold to confirm lah. Okay, this is zinc oxide. Okay, and also you got carbon dioxide. If you got carbon dioxide, meaning what? Meaning what is solid M? Solid M supposed to be what ion to have? First of all, ion to have is you have carbonate ion. Okay, means you have zinc carbonate. Okay, solid M is zinc carbonate. Okay, when zinc carbonate add into nitric acid HNO3. Okay, so you got three things come up. Okay, number one you got solution S. Number two you got carbon dioxide. Number three you got water. Okay, so what do you think solution S is? Very simple. Solution S is your zinc nitrate. Zinc nitrate. Zn, now Zn2 plus, is Zn2 plus 2 minus plus minus negative. Okay, so CO3 with this CO3 we get carbon dioxide, then H and O, you get your H2O. Okay, the last one is your zinc nitrate for solution S. Okay, zinc nitrate will go and react with magnesium. Okay, now since magnesium is more reactive than zinc, okay, what happened? The reactivity series. Okay, magnesium is at the top, on top of zinc. Okay, so the zinc will take away the nitrate. Okay, rampas off the NO3 from displacement reaction. Correct, very good. I have rampas, keep rampas. Okay, displacement reaction, displacement of metal. Okay, learn from chapter 1. Okay, so Mg will displace Zn. Okay, you will get Mg nitrate. So you got zinc and also magnesium nitrate. Okay, so first of all, they ask state 1 chemical test for carbon dioxide gas. Okay, so you can get off. Okay, carbon dioxide, very simple. Okay, bubble the gas through lime water. Okay, lime water turn cloudy. Okay, I'm not sure if you have this set up, no? If you don't have, you just draw. Okay, if you have the day, then um set up to detect carbon dioxide present. Okay, now if you can retort stand, it's not the much thing for you to draw. Okay, I mean this one is just simple. This one is just they want to hit solid M only. They simply want to hit the. I can also if you want to draw also actually no problem also. If you want to draw also can. Okay. But if you don't draw, they won't minus one normally. Okay. If you want to complete also at the beside, okay, you can claim with retort stand also can. Okay. Claim with retort stand also. Okay. So solid M is zinc carbonate. Solid Q is zinc oxide. Okay. Solution S. Now, after that, okay. After that, state oxidation made when excess ammonia solution is added into solution S. Okay. So solution S okay, is zinc nitrate. Okay. So zinc nitrate. Okay. What happened with the ammonia? Okay. So what happened? Now notice and ammonia is to test what ion. Okay. Normally to test positive ion. Okay. You got positive ion is your now is your zinc 2 plus. Okay. Zinc 2 plus is the positive ion. Okay. So when you add Zn3 into Zn2 plus, what happened? White precipitate form. Okay. And soluble in excess of ammonia. Okay. Okay. So you get white precipitate is formed. Okay. After that, precipitate dissolve in extra mean excess. Okay. Precipitate you dissolve in excess ammonia. Okay. To form colorless solution. Which school are you from? Uh, okay. Write the chemical equation for the reaction 2. Okay, so how? Reaction 2 is, okay, zinc carbonate react with nitric acid to become zinc nitrate, carbon dioxide, water. Okay, actually this is one of the uh reactivity of acid. Okay, acid with metal carbonate. Okay, so of course you have to balance the equation. Okay, so you got 2 NO3 here, you got 2 H here. Okay, so you times 2 for HNO3. Okay, name reaction 3. Reaction 3. Okay, reaction 3 is this one you talk about. You give the answer which is displacement of metal. Okay, equation for third one. Let's try one. Zinc plus Mg nitrate. You get your zinc nitrate plus Mg. Okay, so any problem? Okay, move on. Yeah. Okay, page 21. Okay, can I finish one? Move 21. Page 21. Okay, the diagram below shows the reaction scheme of salt Q. Okay, salt Q is heated strongly. Solid R is formed. This solid R is brown in color when hot. Okay, brown in color when hot, turn yellow when cold. Okay, may I know what is this solid R? Brown when hot, yellow when cold. Brown color like a peanut outside skin. Okay, outside skin peanut. When open up is yellow inside. So what is the solid R? Okay, PBO very good. Okay, so PBO. So you know lah. Brown when hot, yellow when cold is PBO. Yellow when hot, white when cold is zinc oxide, the NO. Okay, so you only got one gas when you're heated. Okay, means what? What's the gas? You got one colorless gas, which is your colorless gas. Only one and the only carbon dioxide gas. Okay, if you got two, they say you got two one. Okay, two gas, one colorless, one got brown. Then you got there is not carbon dioxide. Okay, so this one is carbon dioxide. Okay, so if this case you got two already, I'm sure you also can get your salt Q, right? What is salt Q? You got PB, right? Surely the cation is PB. Okay. What since you got carbon dioxide means what is the anion? Correct lah. So you get your final PbCO3. Okay, you get a carbonate ion, get a PbCl3. Okay, so your solid R react with nitric acid. Okay, nitric acid to form. Now, first of all, okay, H and O become what? Okay, and the other one is Pb. We find another partner. We call nitrate. Okay, so what do we form? H2O confirm we form. I mean, H and O is confirmed before. H2O, ma. Correct. Then what is solution Y? Correct. Pb nitrate. Okay. Solution Y is Pb nitrate. Okay. Pb nitrate continue to react with sodium carbonate. What do they form? Same thing lah. I try again. Pb we find another partner which is carbonate. Okay. So for Na we find another partner which is NO3. Okay. So if you get now which okay, this one is sodium nitrate. Okay. Precipitates means PbCO3. Correct lah? Correct lah, because carbonate is insoluble salt. Okay. So for most lah. Okay. So you can write down gas X. Already also one more confirm is gas X also can turn lime water cloudy. Okay. So is carbon dioxide. For Q is lead to carbonate. R is what is R? Where is R? Oh, PbO. Okay, lead to oxide. For Y is lead to nitrate. Okay. Okay. Move on. B. Suggest the type of reaction that occur between solution Y and sodium carbonate. Okay. Write the chemical equation for the reaction. Now, very simple. Solution Y just like you get type 2 nitrate. Okay. That's nitrate, ma. Okay. And sodium carbonate is Na2CO3. Okay. So what happens is, what do you get? Just like you get what? You get, especially you get your insoluble salt. Correct? PbCO3. What is the reaction? What's the name of the reaction that to prepare insoluble salt? Let's see who can remember. Okay, very good. So very good answer. Okay, so you got double decomposition reaction. Okay, this is the reaction to prepare insoluble salt. Okay, so equation you can write. Okay, PbNO3 plus Na2CO3. Okay, it become PbCO3 and NaNO3. Okay, balance equation. You got 2 Na here, nitrate, you got 2. Okay, so times 2 for NaNO3. Okay. In the other question, you can just screenshot. Okay, so salt Y can be obtained through solution Y for solution Y through recrystallization process. Okay, so salt Y is Pb nitrate. Okay, so how do we get Pb nitrate? Pb nitrate is soluble salt, nitrate. Okay, so how do we get the crystal salt again? So you do the crystal. Okay, so what happens? This structure you get heat, cool, filter, rinse, dry. Okay, so you can slowly write down now. After that, after your class whatever, okay, after you're free, I think your holiday you still got a bit time, okay, for you to readjust or everything. Okay, after that you can look at D. Okay, so how do we, what's the difference between salt Q and salt Y? Okay, very simple. So salt Q is your Pb carbonate. Okay, what is salt Y is Pb nitrate. They ask what's the difference when you heat it. When you heat, what happens? Okay, very simple. Carbonate, okay, both will decompose, okay, undergo decomposition. Okay, so one of them, okay, you get your PbO and CO2. This one you get PbO, NO2, O2. When you heat, okay? So residue is brown when hot, yellow when cold. Okay? Because you got PbO. This one is PB. You also got PbO. Okay, same thing lah. Same thing. Okay. The only thing difference is gas lah. Okay. One is colorless gas. Okay. One is brown gas. Brown gas because you have NO2. Okay. NO2. So you got nitrogen dioxide. One is you will get carbon dioxide for heating lead to carbonate. When you heat lead to nitrate, you got nitrogen dioxide and oxygen. Okay. Now, so I don't want to drag too long. Okay. So for the other question, all at the back, you can try to do solely your own. Okay. So if you have any problem, okay. Okay. By the way, my name is Yuan. Okay. So if you want to contact, in case you don't have my phone number, okay. So my phone number is 01827167720. Okay. So if you have any problem, any question you don't understand, you want to refer to me again, okay. So you can ask me again, okay. So because I'm sure you face some difficulty, you have to do question your own. You question with me, oh, very simple, this one maybe can answer, okay. But you try to write out your own, especially for the experimental steps, okay. Surely you get forgotten, okay. So normally, okay, I answer also, okay. You really, you think you are pro in class or whatever, it seems I understand everything, okay. But normally at the back, when you come up for the class, everything fly away, okay. It's very common. Okay, that's why you have to do revision again and again and again. You have to do a lot, okay, a lot of practice. Okay, so that's it. Okay, so I think that's it for today. Okay, so I see you again when I see you lah. Okay, can you explain how to do operational definition? Okay, try to PM me. Okay, this one is paper 3. Okay, I mean, yeah, okay, no worry, no worry. Okay, later I explain to you. Okay, so I'll see you again. Okay, okay, bye bye. No problem, welcome. Bye, bye.